A unity negative feedback control loop system with transfer function g of s is equal to 1 by s square plus 2s plus 2, and a controller is GCS in the feedback forward path for a unit step input. The transfer function of the controller that gives the minimum steady state error. He is asking to find the minimum steady state error. Now we will have to draw the unity negative feedback control loop. GS is given and controller is GCS. He gave GS is equal to 1 by s square plus 2s plus 2, and here there is no any s power and term separately, so it is type 0. If there is no GCS, as it is a type 0, unity step input applied, and it should give finite error. He is asking about steady state error, as steady state error for step input is finite, which is 1 by 1 plus kp. Here kp is the proportional error coefficient, but here he is asking about minimum steady state error. Minimum steady state error is 0. Here only we consider here GS is 0, only GS is 0. As we got here minimum steady state error is 0, let's take, suppose if it is a type 1, then also minimum steady state error is 0. Here we only consider g of s, but actual forward path for type 0 we assume GCS is 0. For actual forward path gain is GS into GCS. For suppose if it is a type 1, as we got for type 0 minimum steady state error is 0, so let's check with type 1. If it is type 1, then there type 0 we consider only GCS is 0. Now actual forward path gain is GS into GCS, so it is type 1 and we consider then GS into GCS. And for type 1 we need a pole at origin. Now let's check the options. Option A doesn't give the pole at origin, and option B also doesn't give the pole at origin. Option C also not given. Now option D is the answer. It is looking like a PI controller because it has proportionality part, integral part and derivative part, and this integral part will give the pole at origin, so this is the answer. And if in options 0 is available, then we take minimum steady state error is 0 at type 0 only.